Independent educational content, views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. Have you ever really stopped to think about the hidden cost to the cloud? Every single time your application fetches data from some distant centralized server, you are paying a massive penalty in latency. Sometimes those round trips take hundreds of milliseconds, which, let's be honest, is an absolute eternity in web time. Today, we're talking about a massive paradigm shift that aims to fix exactly that.
Welcome to The Explainer. Today, we're taking a really exciting deep dive into Akamai EdgeWorkers. If you've been following modern web architecture, you already know that drastically reducing latency is the ultimate holy grail. And the absolute best way to achieve that? Executing your code at the edge, literally as physically close to the end user as possible. Okay, let's dive right into this. Our roadmap for today covers the edge computing shift, enter Akamai EdgeWorkers, architecture and EdgeKV, primary edge use cases, and finally, the serverless future. All right, kicking things off with Section 1, the edge computing shift. To really wrap our heads around this shift, we have to look at the macro context. The way we build software has fundamentally transformed, and distributed applications absolutely require a distributed architecture. Now, what's really interesting about this breakdown of scale is the contrast. Traditional core cloud computing typically relies on just maybe tens of centralized locations. A more distributed approach might bump that up to hundreds. But the true edge, we are talking thousands upon thousands of locations. Akamai's network uses this massive scale to push compute resources entirely out of the core right to the very perimeter of the network. Let's compare these two directly, because it's fascinating. Relying solely on origin cloud computing is kind of like having a package shipped to you, but it has to route through 3 different connecting cities first. Your application is suffering from higher latency, it relies on centralized data, and it's making all these unnecessary network hops. And every hop takes precious time. Edge computing completely flips this on its head. It's like having that same package delivered from a local warehouse right down your street. You get low latency, rapid execution, and your application logic is sitting right next to the user. That physical distance the data has to travel, it's virtually eliminated. Moving right along to Section 2, enter Akamai EdgeWorkers. So what exactly is this tool? Well, EdgeWorkers is Akamai's serverless edge computing solution. It quite literally deploys JavaScript engines across hundreds of thousands of their distributed edge servers. The whole goal here is simple but incredibly powerful. Execute logic nearest to the end users. Think about it. Instead of a user in Tokyo making a request that has to travel all the way across the ocean to a core server in Virginia, the code executes right there in Tokyo. It's all about deploying logic as close to the consumer as humanly possible, totally bypassing those brutal, high-latency origin calls. For dev teams, this is an absolute game changer. You're getting the shortest possible round trip for requests and responses simply because you're chopping out those unneeded network hops. Plus, the developer experience is totally frictionless. Teams can literally just code. You write your logic in JavaScript, and EdgeWorkers is built from the ground up to integrate right into your existing CI/CD workflows. There's no need to overhaul your entire pipeline just to start leveraging the edge. Let's move to Section 3 and see how this builds out practically, architecture and EdgeKV. So, let's walk through a day in the life of a request. It is highly logical and lightning fast. First, it hits the edge platform, instantly secured against DDoS attacks and filtered through a web application firewall. From there, it zips through the API gateway for authentication and governance before reaching the magic moment, the edge function. This is where your custom EdgeWorkers code actually executes. Right after that, the system leverages edge caching and applies acceleration optimizations to route that dynamic response back to the client at just incredible speed. But wait. Here is a massive bottleneck we have to address whenever we talk about serverless computing. If your edge code is running in Tokyo, but it still has to reach across the globe to fetch a user's profile from a database in Virginia, well, boom, you've just lost all your speed advantages. Processing and storing what's known as data in motion absolutely requires having that data sitting right next to your application logic. And that is exactly where EdgeKV steps in. EdgeKV is Akamai's distributed key value store. And it's the vital companion to EdgeWorkers. It's what allows JavaScript developers to actually build data-driven, ultra-low latency applications directly at the edge. By locating the data on the very same edge servers where your functions are running, EdgeKV totally solves that data in motion problem. Say goodbye to retrieving information from a distant cloud. Getting started with this is surprisingly straightforward.
The prerequisites to start utilizing EdgeKV alongside your EdgeWorkers code are pretty simple. You just need to have Akamai delivery products on contract and ensure you have the specific entitlement for the EdgeWorkers dynamic compute tier. Once you've got those checked off, you can access EdgeKV data directly from your JavaScript code or through administrative APIs.
All right, let's jump to Section 4, Primary Edge Use Cases.
The flexibility you get running JavaScript right at the edge opens up some really incredible possibilities. I mean, you can dramatically reduce your origin load with advanced caching and traffic routing, intelligently manipulating cache keys on the fly. You can build out these highly personalized experiences by dynamically assembling content and handling localization right at the point where the user is connected. And it seamlessly manages complex header and cookie requirements without even breaking a sweat.
So the crucial point is this: you can safely add third-party content and ensure strict data privacy compliance entirely at the network edge. Because you've got that compute power right where the user connects, you can literally strip out sensitive personal information from headers or cookies before they ever cross the wider internet back to your origin servers. It's a huge win. You're complying with strict regulations without sacrificing an ounce of performance.
And finally, Section 5, the serverless future. You know, the source material states it perfectly, and this brilliantly illustrates the core philosophy we should all take away today. Distributed applications require a distributed architecture. True scaling, and we're talking both in terms of raw application performance and long-term economic affordability, means moving logic out of those centralized hubs and putting it directly into the hands of a globally distributed network. Which leaves us with this somewhat provocative thought. As edge-native applications continue to eliminate network hops, reduce origin load, and process data globally in mere milliseconds, how much of your legacy cloud architecture could completely shift to the edge? Honestly, the answer might be a lot more than you think. Thank you so much for joining me for this deep dive explainer, and I can't wait to explore more fascinating tech with you next time.